We'll go ahead and, today's presentation is mostly targeted towards those of you or throughout the industry that are unfamiliar with FIPS. And then I will also give an update later in the presentation on where we are in the FIPS 140-3 certification process. If you're not familiar, it's been quite a lift moving from the old program 140-2 to the new program 140-3. And there have been a lot of challenges throughout the industry, not just for us as a company, but for every vendor out there that's doing a cryptographic module. So I'll go ahead and get started here with just kind of giving an overview. What is FIPS? So FIPS is the Federal Information Processing Standards by which historically the U.S. and Canadian governments abided. So it's basically a series of requirements that say, if you're using cryptography to encrypt secure or data securely, and that data is sensitive to federal government, you're going to use this set of algorithms. It tells you what algorithms to use, what key sizes to use with those algorithms. It stipulates which algorithms are not allowed or not approved for use within federal programs, etc. So to that point, they started this back in the 90s. At the time, it was targeted towards hardware. But then as general purpose processors became more advanced and capable, eventually it was possible to do the heavy math required for cryptography on a general purpose processor instead of a dedicated piece of hardware. So the FIPS standards were then adapted at that point to encompass software modules as well, even though they were historically targeted towards just hardware modules. So now our company, wolfSSL, we make a wolfCrypt software library that implements cryptography in software. It's portable. It can run on many different chips. So we call that a multi-chip standalone implementation in software. And that's how we certify it under the FIPS program. Anytime we're moving to a new operating environment, we can retest the crypto module on that environment. We have the capabilities and the engineering manpower to do that retesting. There are other software module vendors out there that might lack some of that resource that we have, and so they might only test one or two operating environments, and then they'll just say, we certify it as a vendor that it's good to go if you port it and run it on these other systems. So our company takes a slightly different approach. We like all of our customers to have that reassurance that their crypto is always certified on the actual target where it's going to be running. And only if they don't require that, that's the only time we would do vendor affirmation or something of that nature. And I'll get a little more into those later on here. So on this slide, what we're showing is a timeline of the 140-3 process. 140-2 is currently being phased out. It will completely go to end of life in September of 2026, and the new 140-3 standard is replacing it. 140-3 testing came online in late 2019, and then you could start doing submissions in late 2020. Our company first submitted in spring of 2021. We had checked in and were doing testing with our lab by October of 2020, and then we ultimately submitted in spring of 21. And that module has now been in process ever since. We haven't gotten a certificate from it yet. And it's currently on hold. The lab that we were using for that submission just got their accreditation suspended. So now we're trying to figure out what we're going to do with that one. But the good news for our customers is we've got a couple other submissions in process as well. One of them is a non-public submission not listed on the MIP list. And we feel that one's going to receive a cert any day now. And then the other one that's upcoming, we're expanding the module boundary to encompass some new algorithms. So that's kind of the timeline. Everyone needs to transition off 140-2 by 2026, and 140-3 will be the only option. 140-3 stand-up has been a little difficult to date. It's taking some time to actually ramp up. But once 140-3 is realized, these are some of the benefits. You know, the 140-2 standard was based off a set of criteria unique to the US and Canadian governments. 140-3 is actually based off the international ISO, IEC standards. So it should be more widely accepted, you know, with European partners, Asia Pacific regions, stuff like that, where, you know, before 140-2 was pretty much only good for the US and Canada. I know this bullet says easier to stay up to date. It's always been easy to stay up to date. So the way we do our certifications, the cryptographic sources get certified, they get locked, they're static, they never change after they're certified. And then we continue to test that with the latest and greatest versions of TLS that we're putting out. That way you're always consuming certified crypto with any patches, CVE fixes to the TLS layer that may have come about. And if we ever did, you know, knock on wood, hope it never happens, but if we ever did get a CVE in the FIPS module itself, we have a way, there's a submission type specifically to address CVEs. It's a rapid approval. You're basically just patching a CVE so the CMVP doesn't hold you back by all these crazy review times that go into, say, a full submission or something else. And there's multiple submission scenarios that you can submit under. I have a slide, again, later in the presentation where we will cover that. For 140-3, a lot of the requirements are a little stricter, but while it's a little more difficult to achieve, it also provides much greater assurance to those consumers of those 140-3 certified modules. The CMVP did make it a lot easier now to achieve hybrid module solutions. They've spent a lot of time and effort making the requirements around hybrid modules clearer and more easily attainable. And what hybrid modules are, so I said at the beginning of the presentation that we do a software module. A hybrid module is where you take, let's say, some parts of the cryptography are implemented in software, and maybe there's a hardware element on that same general purpose processor that implements the algorithm from start to finish. We call that a processor algorithm implementation, or PAI. You can combine now, you know, you can say I'm doing these algorithms in software, these algorithms in hardware, and this is a hybrid module that's doing both. That's what that means. The conditional algorithm self-testing has always been there, but it used to be called power-on self-testing, or POST for short. And it meant that as the module was booting up or being loaded into memory, it had to self-test all the algorithms before any cryptographic functionality could be consumed by an application. With 140-3, they actually changed that requirement. So now you only have to conditionally test the algorithms, meaning if we have, you know, RSA, ECC, and AES all in our module, as it's loading up, we don't have to test them. Only if your application actually tries to use RSA, then it has to be tested at least once before the first operational use. And then after it's run its test at least one time, it becomes optional. So you can rerun it again at a later point if you want to. Like, let's say it's running for 7 days and you just want to check on the health of the algorithm, you could do a quick test to make sure everything's so good to go. So that will greatly reduce the boot up and load times for a lot of our customers. That's a nice change. And then processor algorithm acceleration is kind of the sister implementation to PAI. It's where you're accelerating just the underlying math, like it's a mathematical construct only, not a full cryptographic implementation on hardware. And known examples of that are like the AES-NI instruction set from Intel or the ARM v8 cryptographic extensions on ARM v8 chips. Those are considered PAA, and so you can greatly increase the performance of AES, a lot of the SHA hash algorithms, and even some of the public key algorithms like RSA, Diffie-Hellman, and ECDSA by leveraging those assembly optimizations on specific hardware. And we do a lot of PAA support for a lot of our customers. So, for those that are not familiar with the FIPS program as a whole, these next 3 slides are just kind of giving the background on where it came about. So the National Institute of Standards and Technology is a federal organization that's in charge of coming up with the criteria that will be used to drive development and implementation of any standards that will be used and applied to technology as indicated by the name. And they touch a lot of different areas. One of those areas they happen to touch is the cybersecurity realm, and they write all the standards, and then NIST knew that it was going to have its resources stretched thin because of all the different areas they govern. So they're the ones that stood up the CMVP, which was going to be a dedicated program specifically for evaluating cryptographic modules. Again, as indicated by the name, Cryptographic Module Validation Program. This is the body that certifies modules that do cryptography and issues certificates, and then those certificates get published on the NIST site. Anytime a federal procurement officer is looking to make a purchase of a product that has cryptography in it, that procurement officer will check the NIST site and they'll say, do I see, a certificate for this product I'm about to purchase? And if not, I need a certificate before I can make this purchase and use this cryptography in my federal program. Now, the CMVP recognized that they were also going to be stretched thin, and so sorry, I flipped slides. They stood up a third body called the CAVP, and they're the ones who actually do the algorithm testing. The CMVP then reviews the algorithm testing and checks that you're compliant with all the things outside of the algorithm implementations. So it would be like the self-test, the integrity checks on the module, that all the algorithms you tested and passed through the CAVP, now the CMVP will review and make sure you don't have weak keys in use. You passed the test, but are there things available in your module that would be considered not approved, aside from just the algorithm testing itself? And then the CAVP, yeah, as I mentioned, that's the third body, and they just do the algo testing and algo certs. This is kind of the process we go through. Quick overview of it. So when we're ready to certify a new version of our module, we'll contact an NVLab accredited laboratory that's accredited to do FIPS certification work and review and testing. We'll work with that lab to get our module to what we believe is 100% ready. And once it's ready, they'll submit it to the CMVP. If the CMVP is reviewing the submission and they find an issue, they'll send a comment back to the lab, and then the lab will coordinate with us, the vendor. So we never actually talk directly to the CMVP ourselves as a vendor. We'll get all the things fixed up, and then the lab will resubmit. And this process can happen multiple times, and then eventually, once the CMVP is happy, they'll approve and issue a cert, which then gets published on the NIST website. This is kind of an overview of how we've isolated our module within the greater offering that we have, the TLS library. So we have the cryptographic sources isolated into their own little submodule, and that's what actually gets certified. And that way we can continue to maintain, develop, and update the TLS stack, and then test it with, the 10 to 20, maybe 40 different versions of wolfCrypt that are certified. We can make sure that everything interops well with all the different certified modules, and then we can put out releases to our customers that way. And that way they're always consuming a certified version of wolfCrypt with the latest and greatest TLS stack. Our current offering has all of NSA Suite B in it, and we're actually working right now, we're doing implementations of all the NSA 2.0 suite. So we've now got LMS, XMSS, and Kyber, our own implementations, and then the other post-quantum algorithms, we're still leveraging those third-party like libOQS and other external dependencies, but soon we'll have a complete wolfCrypt NSA 2.0 suite offering that has no third-party dependencies. And the goal for that is, I believe, by the end of this year, we're going to have that complete. And like I mentioned, multiple versions of wolfCrypt have been certified. They all can be consumed by the TLS stack. And then we update the new versions of wolfSSL while maintaining the FIPS validated boundary. I mentioned we have one submission that's on hold, that's on the public MIP list, and one that is not listed on the MIP list. Both of those are version 5.2 flavors of the module. So the one on hold is version 5.2.0, and the one that's being submitted not publicly, not listed on the MIP list, is version 5.2.1. And these are the differences between our old 140-2 certificate and the two new 5.2 versions of the module. So on the old cert, we were doing power on self-test, like I mentioned. Now we're doing conditional algorithm self-testing. On the old cert, we didn't have any of the TLS KDFs or the SSH KDF certified. We were just certifying the algorithms that the KDF was consuming underneath. With these two versions of the module, we're now certifying the KDFs themselves. Same with the SSH. In the past, testing for 3072 and 4096-bit RSA sign and verify operations wasn't available when we started our 140-2 submission. We're back in 2017. Those did become available eventually, and we did test several OEs on the 140-2 cert with them, but with 140-3, that'll all be available on day one. We added OFB mode, AES OFB mode to the module, which hadn't been there previously. We dropped support for triple DES, and then we added a degraded mode of operation. So now if one of the conditional algorithm self-tests were to fail, let's say the sun burped and a solar flare hit the earth and flipped a few bits in your processor while a cast was running, and it happened to fail, that algorithm that failed its cast would go offline. You couldn't use it anymore, but all the other algorithms would remain available to you. And then to get out of degraded mode, you just power cycle the module and you'll be back to the original usable state for everything. With wolfCrypt 6.0, so this is an upcoming full submission we're doing. It's currently on the IUT list. It is checked in with the lab. We have not submitted to the CMVP yet. We're still going through code review and op testing. And we're coining this submission as our SRTP-KDF submission. It's pulling a lot more than just the SRTP-KDF into the boundary and certifying all those new things. But SRTP-KDF was the motivating factor for doing this submission. So that's what we're calling it internally. And it has all the same benefits we saw in the last slide, plus it's adding AES cipher feedback mode, 1-bit, 8-bit, and 128-bit ciphertext sealing. We're adding AES XTS, both 128-bit keys and 256-bit keys. And the reason they're listed as 256 and 512 is this is actually 228-bit keys combined, and 512 is 2 independent and unique 256-bit keys combined for a total of 512. We're adding AES key wrapping to our module. We're adding the password-based key derivation function 2, the SRTP-KDF, like I said, the motivating factor for this submission. We're upgrading from FIPS 186-4 to 186-5, which gives us access to the ED-DSA algorithms now. So we're certifying ED 519 and ED 448. ED 448 actually has a dependency on Shake 256. And we also had Shake 128, so we just decided we're going to test them both as well. And then all the public key algorithms are upgrading to 186-5. And then in the past, when we do our submissions, we usually submit on just Linux and Windows. So we don't have ARM v8 assembly optimizations out of the gate when the cert's first issued. We then have to do that as an OE addition after the cert gets issued. But with this submission, we're actually doing 6 operating environments. It'll be a Windows, a Linux, an Android, and an iOS. And the Linux will have both with and without PAA, and the iOS will have with and without PAA. The Android will be with PAA only, and the Windows will be with PAA only for a total of 6 OEs. And we'll have all the assembly optimizations on day 1. We're also pulling in our single and multi-precision math libraries into this submission. So it'll be the first time we've submitted with the new single precision and multi-precision math libraries that we developed here at wolfSSL. That's all very exciting. It basically just means, extremely fast performance. We benchmarked this against OpenSSL, and on average, we're getting 15% more or better performance above and beyond what OpenSSL can do on the same platforms. So I've used the term OE and operating environment a lot during this presentation. So I did think it was a good idea to have a slide in here that defines what that actually is. So an OE is the combination of the version of the cryptographic module you're certifying running on a specific operating system, and that operating system is passing instructions to a specific chipset. So when we certify an OE, if the details, if the crypto module changed, if the OS changed significantly, let's say it went from Windows 10 to 11, or if the chipset changed significantly, the CMVP will no longer back a claim that that's FIPS certified. And so then your options when those things change is you can say, well, is it a similar enough environment to what was originally tested that we, the vendor, can say, we affirm, and that's vendor affirmation, we affirm that it's going to run the same on this other OE as it did on the one we originally tested. Or you, the end user, you don't even need to go to the vendor. You, the end user, can say, oh, we made the upgrade. We're the one buying the FIPS product, and we feel that it's a close enough environment that we, the user, affirm it. So there's, CMVP backed certification, which carries the most weight, and there's vendor affirmation, which carries less weight, and then there's user affirmation, which carries even less weight. And the ultimate goal of all 3 of those is to convince the procurement officer ultimately buying and deploying the FIPS product in the federal agencies that your module is good enough to satisfy their FIPS requirements. And we've come across several cases now where customers will go with a vendor affirmed solution, because it's cheaper, it's more affordable, and then they'll get to doing their FedRAMP efforts or their NIAP efforts or their JITC efforts, and then they'll come back to us and say, well, that's being rejected. Now we need your solution. So they'll end up paying two different companies, one to get the vendor affirmed, find out it's not good enough, and then they'll come back and pay us to get a real OE certified. And then this part of the slide was deciding which OE is right for you. We're often asked, what should I certify? I've got an application that can run on 100 different OEs, and it's impractical to go and try and certify every one. And in that case, we agree with you, and we'll often, recommend start out with a very common one consumed by your target market. Certify that. Just be upfront and clear with them. Say, look, we only certify it on this one. You might be deploying it on something else. Is it good enough, or do you need us to add that OE that you're deploying on to the cert as well? And then do those on a per, on-demand basis, as opposed to trying to certify just everything out of the gate, because that can be crazy expensive, and impractical. This question came up last year. I kept this slide in here for this presentation just because it's good information. But we've heard, I certified before, and I used to only list my operating system and the form factor on which it was running. Why are you now telling me that I have to list the chipset? And so that's something outside of our control. That's the CMVP stipulated this several years back. It has caught a few of our customers by surprise, if they did FIPS 10 years ago and now they're doing it again today. Yeah, things are constantly changing. The CMVP is always updating their recommendations and their requirements. So just make sure you're up to date on the latest requirements. And if you need some help getting up to date, our support staff is more than eager to answer any questions you might have. This question also comes up quite a bit. We hear about FIPS canisters and FIPS Inside. So our understanding of FIPS Inside was that this was originally something targeted for hardware vendors. Let's say you had a motherboard and an isolated chip that was doing something, and that isolated chip could run on 10 different motherboard flavors offered by your company. You could certify the isolated standalone chip and then just say that chip was part of a larger design, and therefore all the motherboards in your product lines could claim FIPS conformance because you had certified that subcomponent of the larger design. That was the original intent. We have seen some software vendors out there telling their potential customers that, oh, if we just certify this software on Linux, you can deploy it on any box that's running a similar chip. It doesn't even have to be the same OS, and you can consider it FIPS Inside. As far as we know, that's just a myth, and won't pass a lot of muster when it comes to procurement officers evaluating the solution for purchase. So just beware. Make sure whatever your procurement officer requires, you're abiding by that. I guess that would be our suggestion there. Earlier I mentioned there are different submission types, one specifically for addressing CVEs, that's here. These are the 140-2 submission types. They've all been, slightly renamed and reorganized for 140-3. So what we used to call a 1 sub is now an OE up, but also kind of falls under this V8 OE, which is a vendor affirmed operating environment edition. And the difference between the two is a VA OE just updates the security policy and says, we, the vendor, are affirming this other environment, which hasn't been tested, is good in or close enough to the original test that we assume nothing will change. And an OE up is where you actually test on the new operating environment, and then it gets added to the FIPS certificate itself, not just the security policy. And most of these submission types can be mapped over to these, like a full submission used to be called a 5 sub. 4 sub, I'm not familiar with this one because it's for hardware only. It's physical changes to a module, and we don't have to deal with that. But I believe that maps to a FIS, etc. And we can send out this slide deck, so if you're curious, you can go through those at your leisure. When we're adding an OE to an existing certificate, this is kind of the process we go through. It used to only be a 2-month process, and it still can go that quick. But after COVID happened, we did start to see a lot of delays from the CMVP. Their turnaround times got really, really bad for a while. We actually had one OE edition that should have been a 2-month effort take a total of 6 months, which was really long for an OE. So I guess just the point of that being, if you have a tight timeline and you're trying to achieve something in a very narrow window, plan at least 6 months out. If you're just doing an OE add to an existing cert, it can take 6 months. And if you're doing a full submission, we've been in process for over 3 years now with one of our full submissions. So again, just plan accordingly. 1 year to 3 years is not unrealistic for a full submission at present, and 6 months for an OE edition. We've done a lot of work with our 140-3 modules to make sure they're ready to go on a FIPS, on a Linux kernel. So one of my colleagues, Daniel Posner, focuses on this primarily, and he's been testing on a lot of the ARM processors, MIPS processors. We've had a lot of interest in doing a FIPS certified kernel module. So far, nobody has actually taken the bait on that. There's a lot of interest around it, so we have this slide in here. If a Linux FIPS certified kernel module is something that you'd need, it's fully tested with both our version 5.2.1, 5.2.0, and our version 6.0.0 submissions, and it's ready to go. As far as solutions that can benefit from our FIPS module, obviously all of our product suites can benefit from consuming FIPS certified cryptography. We can set up any one of our products with either a non-FIPS commercial implementation of wolfCrypt or one of the FIPS certified versions. And we've also tested it with all these third-party implementations: Nginx, WPA Supplicant, Strong Swan, OpenSSH, Apache, STunnel, Lighty, and obviously OpenSSL. So with the OpenSSL 1.0 and 1.1, they had what's called an engine interface. You could plug in a third-party cryptographic engine underneath, and the whole process would essentially be transparent to the system. All that was required is you compile a cryptographic engine that offers the right API-compatible interfaces. You then modify your OpenSSL configure file, the global configure file on your system, and tell it where your engine is located. You don't have to recompile any of your applications, anything. OpenSSL would then start, as those apps were making calls into OpenSSL, anytime it needed cryptography, it would first check, does the engine offer it? And if so, it would use it. And if it didn't, then it would fall back to the OpenSSL native crypto implementation. And so when OpenSSL's FIPS certificate lapsed a couple years back and they had like a whole year without a cert, a lot of our customers were just flipping over to the Wolf engine and Wolf certified FIPS cryptography to satisfy their FIPS needs while they were waiting for OpenSSL to get their cert up again. And they have the same thing with the OpenSSL 3.0 Plus. It's now called a provider instead of an engine, and we have an implementation of each. So you can plug in our FIPS certified crypto underneath OpenSSL, and then anything that's consuming OpenSSL on your system will be using the wolfCrypt FIPS certified crypto underneath. And then finally, so our current status, I've kind of hinted at it throughout the presentation, but yeah, so we have the 3 submissions in process, the 5.2.0 module, which is currently on hold, the 5.2.1, which is a non-public submission. We just completed round 5 of comments, and those are actually being submitted this morning as we speak. And we feel that one is going to get a cert any day now. And then we have the new full submission in process, which is version 6, and that's pulling in the SRTP-KDF plus all those other algorithms and modes I mentioned on the slide above. And hopefully that one will be submitted by either late June or late July is our goal. And I should mention too, so we do a lot of certifications on Linux, Windows, iOS, Android, but we consider those all high-level systems. We also do a ton of submissions on embedded targets. So we've done, multiple flavors of VxWorks running on smaller systems. We've done FreeRTOS, OpenRTOS. We've even certified proprietary operating systems on very small embedded chips. We've done digital signal processors, FIPS certifications on those guys. And we have an in-house test rig that allows us to do all that. We built our own test harness for processing the CAVP vector files. And even on an embedded target that has no file system, we can still get the testing done. We just use a full duplex UART connection with a request response protocol, and we send over the vectors one at a time for the target to process. It can take a while. I had one digital signal processor that was extremely slow, very low clock speed, and I started the vectors on February 1st, and they ran 24/7, and they finished on February 24th. It took 24 days to do the whole vector set from the CAVP, but we got it done. So even those little tiny embedded targets are not a problem for us. So, and that concludes our presentation. If there are any questions, concerns, comments, feedback, we would love to hear them. And I'll hand it back over to Shizuka. Thank you.
Thank you, Kaleb. There's one question. Kaleb mentioned that one of the labs that wolfSSL uses for their certification recently lost their accreditation. Is this lab the one that was going to be used for wolfSSL version 5.7.08?
No, it's not. So that's a lab we started working with in 2020 when we were doing our original 140-3 submission. They were operating under a different name back then. They got acquired by a higher level organization, and our experience with that lab quickly went downhill. So I don't foresee us doing a ton of work with them moving forward, and certainly not for the 5.7.0 alpha submission.
With another question, what happened with already deployed FIPS 140-2 hardware equipment after 2026? Does it need to be updated to FIPS 140-3?
As far as I understand it, yes. The CMVP has said that, and this is on the landing page, on the home page of the CMVP website, it does say vendors should continue to use 140-2 modules until replacement 140-3 become available. But they, as far as I can tell, have made no exceptions for if it's already deployed in the field, it doesn't have to update. So I guess that would be, that's just my 2 cents on it. Check with your federal procurement officers who's purchasing product, make sure, because that's ultimately who's going to drive the requirements. But from what I have heard and read, I have seen no exceptions that make allowances for deployed products.
There's another question. If the algorithms comes with the hardware, an example, most SoC contain hardware-based crypto such as RSA 4096, AES SHA-3, and it's static. Why FIPS 140-3 is requiring testing the algorithm?
Great question. So if a hardware design offers a baked-in version of cryptography and it has not been certified by that hardware vendor to the FIPS standard, it would be deemed insufficient for use in the federal government because it's never been through certification. Now, if it had been certified, then yeah, you could absolutely use that. But yeah, that would have been tested. And that's why wolfSSL was so excited that they were doing this hybrid scenario where we can say, hey, we're using our same module that we certified previously, but now some of these algorithms are running in hardware and our library is just making it accessible to the end user through our API set. And that hardware has already been certified, and now we're certifying just the remaining software components that are in our module. And we're going to call that a hybrid submission. So yeah, that's when it would come into play. Does that answer the question? Did I answer it fully? I hope.
And then the next question, does changing compiler vendor or version impact an existing certification?
Does it change in the compiler vendor version? Yes, it can. So with the ISO IEC standard, there's now a requirement when you distribute source code. If you're an open source company, you have to include the compiler specifics, the compiler flags, the assembler version, the linker version. All that stuff goes into what's called the Cryptographic Officer Guidance Manual, or COGM. We call it our FIPS user guide. It's the same thing. And so those details are noted in the user guide. And if a third-party auditor was reviewing how wolfCrypt did the certification and how it's being deployed in production, and they were to find a difference in the compiler versions, the auditor may say, this executable binary is not being constructed in the same way that it was when it was approved. And so it can cause wrinkles. But we work very closely with any of our customers that we're doing certifications with. We make sure that, how we're compiling the binary, the tool chains we're using, the assembler, the linker are all identical matches for how they'll be building it in production to avoid specifically that situation.
I have another question. Can wolfCrypt be used in conjunction with M2 NVMe SSDs for data at rest to support FIPS 140-3, so not requiring the M2 controller to support FIPS? If so, I assume the specific M2 SSD become a part of the OE?
Oh, that's a loaded question. So I would say, yes, it could be used. Our software module could be used in conjunction with an M2, as long as none of the M2 hardware crypto implementation was used. Otherwise, we'd need to certify both parts. And for encrypting data at rest, you know, with the new submission we're doing, we're pulling in AES XTS, which I believe is quickly becoming the de facto standard for all data at rest encryption. So that's why we're adding XTS to the module in our next submission. But with the first two submissions, XTS wasn't in there. So I don't know that I could say definitively yes or definitively no. I'd have to see, you know, what is the end use? What are the requirements? Is it ultimately being targeted for a FedRAMP program, an IAP program, a JITC program, or none of the above? And is it being used in the medical field? Is it being deployed on battlefield combat systems? You know, all that would come into play to be able to answer that question definitively.
I have
I'd
another
need to
question.
know a little more.
Okay. Another question. I would try asking for hard dates and timeline estimated on the 140-3 cert before, but can never seem to get a finite answer. Why is that?
Oh, good question. So, you know, we often get asked, when can I expect you to get your certificate? And then fortunately the answer is the CMVP is the controlling body in all this, and we can do all the hard work in the world we want to get everything right. But if the CMVP isn't reviewing our submissions in a timely fashion or giving us feedback and telling us what we need to address or fix, it's impossible for us to tell our customers, hey, it'll be done by June 1st, for example, because we just have zero control over the federal program that's certifying all the modules. So that's why it's difficult for us to give timelines to those asking for them.
Okay. And there's another question. I recently heard mention of an option to do vendor affirmation through another company. What is that, and can you explain it a little more? Does wolfSSL do vendor affirmation?
Oh, I think I addressed most of that in the presentation, but yeah, just to quickly hit on it again. So vendor affirmation is just where the vendor is saying, you know, that the module was tested and certified on one operational environment. It's now being used on a different operational environment, and the vendor, not the CMVP and not NIST, is saying it's good to go. It'll still run the same on that other OE as it did on the one that was tested. The problem with vendor affirmation is that very often when a federal procurement officer is reviewing the solution, they'll say, that's not good enough. We need to see that actually was tested on the OE. And that's when our customers come to us and they say, hey, we need this actually tested. wolfSSL does not do vendor affirmation very often. And when we do, it goes through a very rigorous review and approval process here through our management. Our management just doesn't feel comfortable that they can always say, you know, just because it's a similar chip, it's going to run right. We've seen a lot of times over, you know, we've been doing this for about 10 years now, and we've seen examples like just the compiler changing, and all of a sudden it starts optimizing out global variables that are required for the crypto to run right. And then we have to go figure out, where is the compiler making that mistake? How do we modify our software so it doesn't make that mistake with this specific compiler? And then we fix it, retest it, and submit, and then it's good to go. But if we had just vendor affirmed it because it was close enough, you know, that customer would have ended up with crypto that wasn't running right. And so that's a big risk.
There's another question. Is the wolfCrypt kernel modules available, which Linux version is based on? Are you going to submit the Linux kernel foundation open source mainline as a baseline module?
We do, so all of our FIPS certifications are only available commercially. Unfortunately, we don't plan on open sourcing it. Now, the open source stuff that we do release for FIPS, it's the latest and greatest development heads from our development branches, and we consider them ready for certification, meaning those specific source files have never been certified, they've never been tested, but they're doing all the right things. We are testing them against CAB-P vectors that we know the answers to in-house. We consider them ready to be submitted at a moment's notice, but they're not certified. So there is an open source available version to do prototyping with. You can feel confident that, look, it will pass all the FIPS requirements if we were to certify it. But yeah, we just won't be releasing an open source actual certified version of the Linux kernel module. And as far as mainlining it, I'm not sure on the plans for it, but it is available. You can download it from our website. We have the FIPS Ready bundle up there, so you can get copies of that if you want to test it out and prototype with it. I hope that answers the question.
Okay. And I have another question. You mentioned in your presentation that rebranding is an option once an OE is on cert. What are the benefits of rebranding?
Oh, so rebranding is it's basically a marketing exercise. It's not required in any way, but some of our customers, their marketing teams will want to be selling product from their company only. They don't want to be trying to, pitch their FIPS offering to a federal procurement officer and saying, oh, go look at the wolfCrypt certificate for our operational environment. So what we'll do is we'll certify it, put it on our cert, and then we basically just make a copy paste of our cert, and we replace our letterhead and our logo and all of our contactees on the cert with that organization's contacts, their letterhead, their logo. That way, when their marketing team is selling product, it's coming from their company and they're referencing a FIPS certificate in their company's name. And yeah, it's an optional service. It's a really quick thing we do at the very end of an OE edition effort as optional.
Okay. Thank you, Kaleb, for answering all the questions. And thank you all for your insightful question. And thank you, Kaleb, for hosting the informative webinar. And everyone for joining this webinar today. Please don't forget to follow us on Twitter at wolfSSL, as well as our LinkedIn and YouTube channel. And if you have any further questions, please email us at fax@wolfSSL. And thank you again, and see you next week for benchmarks with wolfSSL. Thank you.
Thanks, Shizuka.